This is where we left off this problem yesterday. I'm going to go ahead and trace out, this is going to be another washer problem. I'm going to go ahead and trace out the washer, and then we'll talk through the rest of the integral work and all that. No, I'm wrong. I messed it up. No, it's not what I want either. -1, -2. All right, and I want square root of 2, and it goes this way. There we go. So first of all, to revolve this around the x-axis, we need to start by flipping it over the x-axis. And then we'll do our revolving. So I'm going to draw a couple of these washers. There's one. Let's draw one more. There. And remember that we decided that the area for these is pi times big R squared minus little r squared. Now, we also need to figure out what our bounds are. That's what the secant of x equals square root of 2 is going to help us find. Because I want to know where these points of intersection are in the left bound and the right bound. And you can probably guess where it's going to be. But hopefully you can also solve this equation and know where secant is going to equal square root of 2, because secant equaling square root of 2 is the same as asking where cosine is 1 over root 2, root 2 over 2. And that is where cosine is positive in the fourth quadrant and the first quadrant. So it is going to be at negative pi over 4 and pi over 4. What a coincidence. All right, so those are the bounds of our integral. We are going from negative pi over 4 to positive pi over 4. Of, well, we need to know what our big R and our little r are. Big R is our farthest distance out. So here's our big R, and it goes all the way up to the horizontal line. The horizontal line is our y equals square root of 2, down to 0. So if we're thinking about this as like top curve minus bottom curve, it's square root of 2 minus 0 is square root of 2. So that's our big R. Our little r is this distance right here. It is our bottom curve. So that's going to be secant of x. So writing this formula out, pi is going to go out in front. We already figured out the bounds. And we have square root of 2 squared, that's big R squared, minus secant of x squared dx. And I won't show out evaluating the entire integral, but I will do this simplifying first. Pi times the integral from negative pi over 4 to pi over 4. And guess what? Square root of 2 squared is 2. Secant of x squared is secant squared dx. And the nice part about that is that we know these are pretty easy antiderivatives. Antiderivative of 2 is 2x. An antiderivative of secant squared, well, secant squared is the derivative of tangent. And so this antiderivative is pi times, we have 2x minus tangent of x. And then we plug in pi over 4 minus plug in negative pi over 4. And you're not here to watch me evaluate out trig stuff. And so I won't show out that whole thing. But you should get pi squared minus 2 pi. Units cubed. Mostly focused on our setup process. And just so that you see, let's see. From negative pi over 4 to pi over 4. So there's that. But then we also want to do it for this function. Boom. Here's the thing we just found the volume of. So again, hollow on the inside because it's a washer. The blue is that square root of 2 function. And then the red is my secant function. So that is the thing that we just found the volume of. That is what it looks like. Questions on how we did any of that? All right, let's move on to our next one then. All right. This time, I want to give you a minute. Actually, let's graph this one together. All right, so first off, we're going to revolve this region around the y-axis. Let's start by graphing our easy ones. Our easy ones are x equals 0. Well, that's just the y-axis. So that's what we're going to be turning this around. But then we have y equals -1 and y equals 1. Those are horizontal lines. Let's give myself a bit more space than that. Those are horizontal lines down at -1 and +1. So here is -1, here is +1. And then we have square root of 5 times y squared. Well, square root of 5 times y squared, x equals y squared, is just a sideways parabola. And then the square root of 5 is going to stretch it out a little bit, but it's going to be a sideways parabola. So I'm going to draw out, let's see, 0, 0. I'm going to draw out a sideways parabola. It's opening out to the right since it's positive. And then our other boundary is the y-axis. So here and here. So that is my region here. Now, here's the new part, is that this time, usually we've been spinning it around the x-axis. That's what we did the entire rest of the time here. We took it and spun it around this x-axis. This time, we are taking this and spinning it around the y-axis. So we're going to draw out, first off, we're going to reflect it over the y-axis. So let's go ahead and draw out my sideways parabola just out in the other direction. Okay. And then because it all funnels and feeds right into the y-axis, this is actually going to end up being a disk instead of being a washer. So my disks look like here, and let's draw another one here. Let's draw another one here. This is what my disks look like. So like a whole bunch of disks, they narrow out and then they expand out. So you should be envisioning almost like an hourglass, basically, is what this thing looks like. Right, because these circles get wider and wider as we go down, as they funnel down. It's almost nothing at 0, and then it widens out again. So it's basically like an hourglass shape. Huh? I don't think so. Because it's in terms of y and it's around the y-axis. I'd have to play with it a little bit. I don't have it all set up. But yeah, hourglass type of shape. Okay. There, and there. All right. So that means it's just going to be pi r squared. Because we just have a disk this time. We just have the circles. Instead of having to work with a washer. So we want to find what our radius is. Our radius is this distance right here. Or down here with this disk, it's this distance right here. And since I have everything in terms of y, I'm going to keep it in terms of y. So in other words, that ends up being, that is an x distance. So that x distance, written out in terms of y, is square root of 5 times y squared. That's our radius. So when we write our integral, since we are, well, let me get this out first. There, squared. All in terms of y, so dy. And then our radius was square root of 5y squared. And since we are in terms of y, our bounds this time should also be in terms of y. So instead of left bound and right bound, farthest left and farthest right, this time we want lowest bound and highest bound. So our lowest bound, well, this is what sets our boundaries. This is our lowest value for y. This is our highest value for y. So we go from -1 to +1. And I'll just show one more step here. And then I'll leave you to kind of figure out the rest, because this is a pretty easy one. Let's see. Square root of 5 squared is 5. Y squared is, oh wait, there's a pi out here. Pi here, pi here. Okay, there we go. That's better. And then y squared is y to the 4th. dy. And then antiderivative, plug in 1 minus plug in -1. That one would be pretty easy for you to figure out. And this is not the take the antiderivatives of plugging of polynomials chapter. This is the volumes with disks and washers section. So that's what we're going to focus on. So any questions on the setup of that one? So we were in terms of y because this time we went, our disk went out a horizontal distance. That was our radius. So the horizontal distance was an x distance. And what is x? X is 5y squared. So we're going in terms of y. Uh, 2 pi is your answer. All right, let's do one more. And then when we come back next week, I'm going to give you a couple free responses that we're going to do together in class that are going to put like all these together. I'll give you about 2 minutes. See if you can draw this out here. So part of what you should have in the first quadrant, so you should be focused in the first quadrant, then we'll spin it around our x-axis. So below by the x-axis, on the right by x equals 2. There's x equals 2. So graph what x squared looks like in the first quadrant, and then spin it around the y-axis, and try and draw out your disk or your washer. And then see if you can figure out what your R is, or if it's a washer, what big R and little r are. x squared doesn't go down here. It never comes down here. We're spinning it over the y-axis. Here's something that should help you guys out. Remember that we are spinning this over the y-axis, and it's y equals x squared. So that means y equals x squared should come like this. And we are not flipping this over the x-axis. We are going to flip it over the y-axis. So we're going to rotate it around this way, not this way. So those of you drawing something down here, nothing should be down here, because we're not rotating it over the x-axis. We're rotating it over the y-axis. So we're taking this region, and we are spinning it around the y-axis. And hopefully you've spotted that this is going to be a washer. So see if you can work out what big R is and what little r is. Since we're spinning over the y-axis, we should be in terms of y. What's our big R? Our big R is our distance all the way out to the vertical line, so it's always 2. No matter where we are, big R is 2. Right? If I put the washer up here, the big R is still 2. Then we want little r. Remember, we want it in terms of y. So instead of writing y equals x squared, I'm going to write x equals square root of y. So that our little r is square root of y. That is this shorter distance out to this point. This is square root of y. So that means our integral in terms of y, we're going to put a pi out in front. It's going to be big R squared minus little r squared. So that is 2 squared minus our little r was square root of y squared. And again, this is in terms of y, so our bounds need to be in terms of y. So instead of thinking of how far left and how far right, these washers go out from bottom up to top. That's why we're doing it in terms of y, because the washers go from bottom to top. So that's how I need to think about my bounds. Since we're going from bottom to top, that's in terms of y, and so our bounds also need to be in terms of y. The lowest point is 0. The highest point is at the x-coordinate of 2. Well, when x is 2, y is 4. right? This point is at 2, 4. So our highest washer is up here at y coordinate of 4. Final answer, I believe, is 8 pi. Yes. Again, that's a pretty easy antiderivative. Because once again, I have square roots that I'm squaring. And wind up getting that. Questions?